Hi, today we're going to be talking about perfect squares and how to represent them on this geoboard. Now, what exactly is a perfect square? A perfect square by definition is a number that can be represented as the product of two identical integers. So let me show you an example on the geoboard. In order to use the geoboard here, we're going to grab one of these rubber bands and we're going to drag it to the pegs. You can drag them to any length across the geoboard. In this case, we're going to make a 3x3 square. It's important to have the squares have the same length and width because that is how we show a perfect square. Okay, so here we have, I'm going to write this down, a 3x3 square. So how would we represent this as a perfect square? Well, how do we find the area of a square? We take the two sides, so in this case our sides, and we multiply them together, or we square them together. And this is equal to our area. In this case, our area is equal to 3 squared, which is equal to 9. So 9 is a perfect square, and it's represented as 3 times 3. So we're going to now look at a worksheet. We already showed an example, so I want you to work on these next ones by yourself and find the area and the perimeter of these lengths. You've already learned about the perimeter and you've been refreshed about area, so I want you to go through this and write down each of the ones. So you're going to work with your class and in order to find the answers with that, and the teacher is going to pause the video, and once they unpause it, we're going to work on question 2. So pause the video now. Alright, let's move on to question 2. A number is called a perfect square if it represents the area of a square whose side length is a whole number. For example, 25 is a perfect square because 25 square units represents the area of a square with a side length of 5 units. Which column above shows perfect squares? Now, you're going to pause the video now and discuss this among your peers, and I'll have the answer once you unpause. So, the answer for this, we have to look at the columns and see what they represent. Now, we showed before that 3 times 3 is equal to 9, and 9 is our perfect square. So, if we look at 49 square units, in order to get the area of that, we would need to multiply it by 7 times 7, and those would be our side lengths for it. So 7 times 7 is equal to 49, so 49 is a perfect square. So that means that each of the areas in these columns represent the perfect squares. All right, we're going to move on to the next question. The next question wants us to try to construct as many squares with our geoboard as possible. Now, what you're going to want to do is you're going to want to work together, and your teacher's going to pause as you work on these. All right, so we're going to then unpause the video and show how to do some of these examples. All right, so pause the video now. All right, so now let's go back to our geoboard. We're going to clear this off with this button right here. All right, so here we're going to go. So we're going to work on how you would answer these questions. So we need to think about how big we can make this. Well, you can make a perfect square for however big you can make a square with the same dimensions in this. There are 15 pegs for the length and then 10 pegs for the width. That means that the largest thing we can make has a length of 14 and a width of 9, which means that the biggest figure we can make is a 9 by 9 figure. So let's make that right now. All right. Let's make sure to get this correct. Let's make sure not to overshoot. 1, 3, 4, 5, 6, 7, 8, 9. All right. We're going to just crease this really quick, stretch the rubber bands across, and we've created the largest perfect square we can create in this area. So when we have this, we have a side length of 9. So our area is equal to 9 squared, which is equal to 81. If we take the square root of 81, we are given back to 9 being its square root. And that's basically a good way to check if it is indeed a perfect square. So now, what you can do is you can do all of the small perfect squares in the middle. So let's do the absolute smallest. How small can we get with our current Geoboard? Well, believe it or not, 1 is a perfect square. 1 times itself is 1. So in this situation, our smallest possible perfect square has a length and a width of 1 unit. So 1 squared is equal to 1. So that's like the smallest you can do, and you can fill in the rest for the other ones. 2 times 2, 3 times 3, all the way up to 9 on this particular Geoboard. If our Geoboard was bigger, then we could keep going for as much space as we had. Alright, so you can see a trend there on how the perfect squares work. Alright, so let's move on to our next question. Alright, if you know the side lengths of a square, how can you find the area without a Geoboard? So you're going to pause and you're going to discuss this with your class. So pause the video now. Okay, well, let's go and look at how to calculate the area without a Geoboard. We've already been showing this without the Geoboard, but now we can show it just without the representation. So let's say that we have a side length of 3 like we had before. We know that the area is equal to S squared. So in order to calculate this, we get 3 squared, which is equal to 9 units. Sorry about the sloppy handwriting. Squared. So that's an easy way to calculate the area without having to show representation. It's a little bit easier to visualize it along with doing the calculation, so that's why I've been showing it to you. Alrighty, let's move on to the next question. If you know the area of this square, how can you find the lengths without a Geoboard? Now, you're going to pause the video and discuss this with your group, so pause the video now. Okay, this can be a little bit tricky. Alright, so if we know that, let's say that we have a area of 25 square units. Alright. So, how could we figure this out? Well, if you think about it, how did we find the area when we only had a side length? We squared it. So, the best course of action in this case would be to take the square root. So the square root of 25, we take that. It's equal to 5, because if we look at our area, it's equal to 25, which is equal to our side lengths squared. Taking the square root of each gives us our side length of 5 units. So that's an easy way to show it without having to show a visual representation of the area. So now let's go on to our final one. What is the relationship between the side length of a square and the square root of its area? Now, you're going to pause the video and then you're going to discuss it with your class. Alright, so pause the video. So what is the relationship between the side length of a square and the square root of its area? Well, like we showed in this example here, we're going to find the relationship by looking at what the two pieces represent. If we look at the length of this side, in this example, it's equal to 5, and the area, which is equal to 25, we see that when we take the square root of 25, we're able to find what the side is equivalent to. And this goes and shows us how perfect squares work. It shows us that when the sides are multiplied together, these two equal sides, 5 and 5 in this example, we're able to find the perfect square 25. And that shows us our relationship between not only the area, but how perfect squares work in just area, and if you think about it, it could work in a lot of other cases as well, which is something that you're going to want to think about. So thank you so much for watching this video today, and goodbye.